Hello everyone, welcome back to ConArchy YouTube channel. In our previous videos, we've learned how to model simply supported beams and trusses, how to assign our loads, that's our point load, uniform distributed load, and also varying distributed loads. We've learned how to analyze our frames to get our shear force and bending moment diagram. In today's video, we are going to do something a little bit different, but quite similar to what we've been doing over the previous days. We are going to model this building here. This building is spanning 22 meters in this direction and also 18 meters in this direction. So we have two different columns in our building. We have column type C1 and also column type C2. So with this, we have our column type C1s as our exterior columns, and we have our C2s as the interior columns. So this is a typical detail of how the columns look like. So we have our C1 to be 300 by 300, and we have our C2 to be 450 by 450. Our C2 is quite bigger since it's an interior column, and definitely it's going to carry like more loads. We've not really done the analysis, but looking at this, we know that it's going to carry more loads. So we have some information down here. The depth of the slab is 150 mm. The beam size is 400 by 300 mm. And our story height is going to be 3000 mm. So the story height is going to be the same throughout the building. So is the beam. So now we are okay with every detail in this drawing. So let's go back. So our first thing before we start, if you've not liked or subscribed to our channel, do so before we start today's video. So first of all, we are going to open our ETABS app. So it's a new model we are going to work with today. So we are going to click on new model. So with this, you have to select use built-in settings with. So I already have some units of measurement and some codes already selected here. These are the ones I'll be using in my design. I'll be using metric SI for our display units, and I'll be using BS codes throughout my design. So if yours is quite different and you need to make some changes, you already have to change everything here. So you can go with US customary if that's what you're using for yours. And also for the codes, design codes, you can change it just in case you are using the Chinese code. You also have the Indian Euro code and everything. If that's the code you're using for your design, you have to change everything to your preferred code. But I'm not going to change anything since these are the ones I'll be using for my design. So all I have to do is click on OK. So as a structural engineer, before you start your modeling in ETABS, the very first thing you have to do is set your grid lines. This is something that is very simple for a structural engineer to do. So let me take you through how to create your grid lines. So let's go back to our image. So this is our plan view. We are going to see the grid lines in our X and Y direction. So we are going to specify the grid lines. So we are going to specify the grid lines that are cutting through the X direction. So in the X direction, we have our first grid line cutting through, second, third, and fourth. So total, we have 4 grid lines that are cutting through the X direction. So we are going to input that value here. We already have 4, so we are not going to change anything. So let's go to number of grid lines in Y direction. So our number of grid lines that are cutting through the Y direction, we have grid line 1, 2, 3, 4, and 5. So in total, we have 5 grid lines that are cutting through the Y direction. So we are going to input that here. So 5. And the spacing of grids in X direction. So the spacing is just the dimension or the distance between our grid line. So that's the spacing. And in our x direction, we have 6,000 millimeters. That's 6 meters. And looking at this, it's quite uniform, meaning we have 6 meters throughout. So 6 meters, 6 meters, 6 meters. So in our spacing of grids in x direction, we are going to input 6 because our units are in meters. But if it was supposed to be in millimeters here, we will just input 6,000. So we are just going to look at the spacing in the y direction. So that's also 6. But let's go back to our image and it looks. So in our y direction, we have 6,000 here, 6,000, 6,000. But looking at the last dimension, we have 4,000. So what do we need to do? We have to customize our grid spacing to suit this structure. So custom grid spacing, we are going to edit our grid data. So first of all, we are going to select display grid data as spacing. I've told you several times why we are going to use this, because as ordinates is just a summation of the measurements. So we have at grid point A we have 0, at B we have 6, so just summation. So 6 plus 6 you have 12, then plus another 6 we have 18. It sometimes makes your reading of the measurements complex, so I prefer to use a spacing. So spacing just displays the exact spacing between the grid lines. So we have 6 meters throughout. So we are not going to change anything here in the x direction, but we need to change our last value. That's the 4,000 mm. You have to change it here. So our 4,000 is going to be somewhere around here. So we have to edit this grid lines. So we have to notice that whatever you change here, it replicates here. So we are going to just minimize this dimension to 4,000. So with grid lines, we have grid line 1 and grid line 2. So 1 and 2, where do we have 1 and 2? This 1 and 2. So this is the spacing we are going to change. We are going to change this to 4. You'll notice that the moment I tap enter on my keyboard, this spacing is going to decrease to 4 meters. So just look at that. Look at that. See, this spacing has decreased to 4 meters. So now everything is intact. You just click on OK. Just looking at the bubble size. The bubble size is quite okay, so I'm just going to leave it as such. I'm not going to change anything. Then I'm just going to click on OK. So let's come to our story dimension. We have to change our values here. So the number of stories, let's stick with 2 stories for the meantime. But as we go on through the video, we are going to increase our number of stories. And our typical story height, with the info at the bottom, we know that the story height is 3,000 meters throughout the entire building. So 3,000 meters, that's 3,000 millimeters, that's 3 meters. So for the typical story height, 3 meters, and also bottom, we are going to leave it as 3 meters. We are not going to customize anything here. So once you are done with all of this, all you have to do is select grid only, then click OK. So we are going to wait till the grid lines pop up. So this is how it's going to look like. We have our plan view here, and we also have our 3D view here. So for this 3D view, you can rotate it in whatever view you want to just look from. So all you have to do is click this 3D window. After clicking it, this window becomes active. Then you have this rotate icon here. So click on rotate, and you just be rotating and just looking at any view you want. So that's how we are going to create the grid lines for this model. In our next video, we are going to learn how to modify, we're going to learn how to define our materials, how to define our section properties for our materials. We know we are going to be using concrete and rebar. This is an RCD, reinforced concrete design, so we are going to use concrete and our rebar. And we are also going to define our sections in our next video. So before you end it, you have to save this, since our next video we are just going to continue with the same thing. So we have to save this, save as, and let's pick a unique name like building. So we are going to save it as building. So save. So in our next video we are just going to just continue with this same file. So that was it for today's video. If you like the video, don't forget to subscribe and also like today's video so you don't miss an update. Thank you.